Okay, we're going to talk about electron configurations and how to determine the electron configurations of different elements. You should be able to do this on your own before you move on. Okay, so just a reminder, element versus a compound. Elements, stable elements are on the periodic table of elements, and they react to form compounds. By the way, make sure you have your guide notes open and you're following along as you watch this video. Compounds have two or more elements bonded together with a specific chemical formula. Okay, electron configurations, we use our orbital filling diagram. You really need to make sure you remember that the s orbital holds up to 2, the p orbital holds up to 6 electrons, d holds up to 10, and the f orbital holds up to 14. And then this is the notation we use for an electron configuration. So it tells us where each electron is found in an atom of an element. The 1 here in front of the letter tells us which suborbital it's in. The letter tells us which orbital, S, P, D, or F. And then the exponent number here tells us the number of electrons that are in that suborbital or subshell. So we use the orbital filling diagram to determine where our electrons go. We fill it out as we go until we run out of electrons, and then we write our full electron configuration. Okay, review real quick. The atomic number tells us how many protons a stable element has. If the element is stable, that means it is equal to the number of electrons. It means it doesn't have a charge, so there's the same number of protons as electrons, right? So we can use the atomic number to tell us how many electrons an atom has. The group number of an atom tells us the number of valence electrons, or the outermost electrons that are in that atom. I always think of a stair. Each step is an energy level moving up and away from the nucleus. So 1s is the first step, 2s, 2p would be on the second step, 3s, 3p would be on the third, and then moving forward, okay? So here's our example problem number 1. Question is, what's the full electron configuration of the element potassium? Okay. So what group is the element in? If you look at your periodic table, potassium is found in group 1. What is the atomic number? Potassium has 19 total protons, which equals 19 total electrons. So I'm going to put 2 electrons in the 1s orbital, 2 electrons in the 2s orbital. 2p orbital is going to have 6 because I can fit up to 6 here. The 3s will have 2 electrons, and then 3p will have 6, and then the 4s will have 1 electron. I only have 1 electron left. My numbers here should all add up to 19, which they do. And I know that potassium is found in group 1, so it should have only 1 electron in the outermost energy level. That outermost energy level is 4s. So writing out the full electron configuration for potassium, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. 4s is my outermost level. It has 1 valence electron. Okay, example problem number 2. What's the electron configuration for oxygen? So atomic number of oxygen is 8. It's in group 6, so it has 6 valence electrons. I'm going to put 2 electrons in the 1s orbital, 2 in the 2s, 4 in the 2p. Now I'm out of electrons. So the outermost energy level has 6 electrons. I'm counting the 2s and the 2p on the same step. They're on the same step of that stair. Okay, full electron configuration for oxygen is written as 1s2, 2s2, 2p4. There are 6 valence electrons here in this outermost energy level. All right, so quick summary. We use the orbital filling diagram, atomic number, and group number of an element to write the full electron configurations for elements. Good luck on your practice.